Okay, fine. So first we will understand requirement of project, like what we are going to do and how we are going to do. Then we will start with development. So first we will do create YAML file and then we will develop project. So what all steps we are going to follow? Understand requirement. So we have requirement about this project. Then create YAML file. So based on requirement we will create YAML file, and then we will develop API using YAML file. Then we will do testing, and at the end we will do code checking. Like we should have some, means in every project you will get some center repository where you will keep your code. Okay, so after development where we will keep our code, so we will create git repository and we will do checking there. Okay, so all these steps we are going to do, and we will do after testing, we will do is unit testing also. Okay, so we will create unit testing, and then we will do unit testing also. So first let's understand objective of this exercise. So what we are going to here to simulate real world scenario. So here we will simulate one real world scenario. What scenario is there? So we'll explain after this. Where a solution architect document will be handed down to the development team. So if you go down, then you will see like we have one complete document. What you will get in, means from solution architect in when you will start working in any company. So they will provide you some document. Either they will provide you Jira story, or they will provide you functional design document. So this is a functional design document. You will go through this functional design document and then you will start implementation. Make use of Mulesoft out of box capability. So in Mulesoft we can see we have multiple components. Okay, so same task we can, for same task we can use two component. Okay, but if you will use one component, then your program will be very effective, and it will take, your API will take very less time. Either approach, means other approach if you will follow, then maybe your program will be very complex and it will take more time to execute. So you have to think what all out of box capability you will use to make your program more efficient. Okay, for example, as I told, we have for each and we have parallel for each. Okay, if we will use for each, then each record will be processed in sequential way. For example, we have 1000 record, then one by one it will process all the 1000 record. So our processing time, for example, for processing of one record it take 2 seconds. Let's say like it's taking 2 seconds. So if we will use for each, then we have 1000 record and each record taking 2 seconds, means total time it will take 1000 into 2 means 2000 seconds. I'm just taking a random value 2 seconds. Ideally it will take very less, like it will take in millisecond, but I am taking in seconds, so you will able to correlate. So in this case it's taking 2000 seconds. But if I will do in parallel for each, then multiple thread will start parallelly. Okay, for example, we have defined batch size equals to 100, then 100 record will be processed at a time. So total how much time it will take? 1000 divided by 100 means 10 into 2, it will take only 20 seconds. So we have lots of mule component. Okay, so we have to think which component will be best suit for our requirement. Now you will say, then why for each introduce, like if we can do in parallel for each, then why for each is there? There may be some, means in multiple scenario there will be some limitation. You can't use parallel for each. In that case, at that time you have to use, means you can't execute records parallelly. If that kind of restriction is there, then we will use for each. But if we don't have any restriction, then we should use parallel for each. So it will save time and our API will be more efficient. Okay, in this way we have multiple things like scatter gather we have. So we'll show you how to use scatter gather and all. Okay, if anyone know, then well and good. Otherwise, anyhow, we are going to cover that topic in training session also. What is scatter gather, how to use. So, okay, let me give you one high level overview to explain this second point again, like in detail. So, for example, we have requirement like we want to call two external system A and external system B. Okay, if input of external system B, okay, just give me 1 minute. I will create one diagram so it will be more clear for you. So, for example, in my project, like for example, you got one requirement and you want to call these two external system A and external system B. Now, if output of system A are going to use as a input of system B. Okay, so in that case, we have to call these two external system one by one. First, we will call this system, we will get response, then we will use response of this external system as a input of this second external system, and then we will call second external system, and then we will complete the process. So in this way, we don't have any option. We have to call it in sequential way. But many a time you will get means you will not have any kind of dependency in between these two external system. So what you can do, you can call it parallelly. Okay, for example, input of this external system B is not dependent of output of external system A. So in that case, you can call parallelly. If this call taking 5 seconds and this call taking 3 seconds, then in maximum in 5 seconds, both we will get response from both external call. But if we will use sequentially, then it will take 8 seconds. Okay, if we are calling sequentially, then it will take 8 seconds. If we are calling parallelly, then maximum time. What is maximum time? 5 seconds. So total time will be 5 seconds for getting both response from both this system. Okay, so in this way, we have to understand Mulesoft out of box capability so that our API performance will be good and our API will give response in very minimum time. Okay, so this kind of capability you have to means think like what component you should use. Okay, next, include previous best practice experience when coming out of the solution. So again, similar to this, like whatever you have learned in your previous project, you have to use best practice what you learned from previous project. Make use of design center to create RAML. Okay, so whenever you are going to create any API, try to create RAML file. Okay, there may be some scenario where your API don't need any RAML file, like if your API is scheduler based. Okay, in that case, you may not require any RAML file. Okay, if your API is file based, in that case also, like you don't need RAML file. But whenever you want to create REST API, means you want to expose your API as a REST API, always try to create RAML file. Okay, and I think it should be mandatory for each and every project. Okay. Okay, so for creation of RAML file, where we will create RAML file, we will create in design center. And everyone familiar with this, like where we have design center, we have Anypoint platform. Inside Anypoint platform, we have lots of capability, and design center is part of that. Okay, so we will create RAML file in design center, and then we need to follow RAML best practice. What is RAML best practice? Okay, in RAML, what you can do, you can define each and everything in a single RAML file. Okay, technically it's not a error, like it's not an error. but means your YAML will be very complex. After you once you will develop your code, maybe someone want to review your code. If he will go through that YAML file, he will not able to understand that YAML file properly. Since your YAML file, actually if you will work on real time project, then there will be lots of things. Okay, so you have to define everything in your YAML file. So your YAML, in that case, YAML will be very complex, and someone want to review your code, or for example, you completed any project and after some time that project needs support. For that person also, it will be very difficult to understand if you put everything inside single YAML file. Okay, so what we will do in YAML based practice, we will try to identify reusable component, like what components we are using multiple time. Okay, so what we will do, we will remove that component in separate file, and we will use that component. Okay, so how we can do that, I will explain later once we will start working on YAML. So first we will create one YAML file using this lengthy approach, like we will put everything inside single YAML file, and then first I will show you what all things and how we can separate from main YAML file. Then you will able to correlate thing, you will able to see difference. Okay, so at that time you will able to understand what do you mean by the means what exactly mean by YAML best practice. Okay, then organize and create the multiple project based on the business scenario. Okay, so what will happen, like in a single application you will create multiple requirement. For example, in this project we have two things like get route and get schedule. Okay, in similar way, if you will work on different project, in a single application you will try to achieve multiple functionality. Okay, so if you will put everything in a single file, mule configuration file, where we do our development, code development, if you will put everything in a single file, then again it will be very difficult to understand, even for you also and some other person also. So what we will learn here in this means what we will do in this part, we will try to separate flow. Okay, so how to separate and all we will discuss while we will do implementation. Okay, then create mule message flow making use of mule component and connector. So everyone familiar with component and connector? Mule component means whatever components like this variable, set payload, then we have choice, we have for each, parallel for each, so all these are known as mule component. And then connector means whatever we use to connect with external system, like HTTP connector, then file connector, FTP connector, JMS connector. Okay, so we will use all the component, means we will use mule component and connector to achieve our business requirement. Then unit testing. So once we will complete our development and we'll do local testing, then we will write unit test script to do unit testing. So there also we try to means do some kind of testing that I will explain again later on. Once we will go on that part now, I will explain how to do and all. Then test script creation to test the endpoint using testing tools such as Postman and SoapUI. So everyone familiar with this Postman, so we will use Postman to test our application once we will develop test once we will complete our development. Then once you will complete everything, you will demo. Okay, and then extend the enhance your application in real time. Okay, so anyhow we are going to do in real time only now. So from here actually your actual documentation start, like you will try to understand, like first you will understand business scenario, and then we'll discuss about flow, then sequence diagram, and then we will discuss about API. How many API we will create, we will discuss about all those API. So first business scenario. So here we are going to create one application, means we are going to create API for TripEG. So TripEG is a startup company providing a platform to perform booking service for land, air, and sea transport across the world. If anyone of you have used this Make My Trip, Go IBBO, we have multiple websites, similar kind of website. They also provide similar kind of service. You can go to their website, you can book any kind of transport, like you can book bus, you can book train, you can book flight, you can book cargo and all. Okay, so TripEG also provides similar kind of service. Okay, now this platform will enable customer to query location, route, and departure schedules. So using this platform, user can query about routes, like what all routes are there. For example, there is a route from India to US, one route from India to UK, another route is Singapore to Japan. So these are routes. So you can query about routes, like what all routes provided by particular service provider. Actually, we will discuss about service provider. So okay, and then schedule. Okay, so we found route, like I want to travel through flight and I want to go from India to Singapore. Okay, first I will check that route is available or not. And it means there are many company who provide flight service from India to Singapore. So I just want to check, like, is there any route for any flight or not. If not, then I will go through another way. So that kind of query you can do. You can check about route. Then schedule, like I searched for route, I got yes, there is a route from India to Singapore for this particular transport provider. Then I will check what all schedules available for that by that transport provider. So once I will click on that API, I will call that API. That API will give, okay, you have means we have flight at this time on this day and we have available 20 seat. Okay, so route will give detail about routes, and this schedule will give complete detail, like how many seats are available, what time flight will go, what is how many seats, and then other information you will get. Okay, this platform will connect to the respective transport provider, as I told. So this is just a platform. They don't have their own services. They do booking for different transport provider. For example, we have Cathay Pacific, we have Air India, we have Indigo. So we have different kind of transport provider. Okay, so what this TripEG do, they are doing booking for this transport provider. Okay, so what this platform will do, whenever this platform will get any query, TripEG will get any query, they will call this transport provider API to get detail. Okay, and then they will call their API and they will get all the detail. This platform will connect to the respective transport provider backend system, okay, to query for the available route and schedule and make purchase, track their booking and make change of their booking. This platform will also provide the capability for the regulatory agency to manage their booking, and all update will be reflected to the transport provider backend system. Okay, so we'll call their API for different purpose, but mostly we will be focused on route and schedules. Okay, other thing we are not going to implement. If we will implement everything, then it will take more than 3-4 months, but we will try to complete this project in 1 month. Okay, so we will be focused on this route and schedule. For this only we are going to create, I think, almost 7 to 8 API. Now you will have more clear picture here. So actually we are going to implement this entire thing. Okay, so these two are transport provider, Travel on Tip and Fast Go. Okay, so these two are transport provider and they have their API. So this diagram denotes their API, which is connected with their database. Whenever we will do any query to their API, like for route or for schedule, they will connect with their database and will give detail. Okay, same to fast go booking service. Okay, now before going to discuss this three layer, I hope everyone know about this API LED architecture. So still I will explain once, like what is API LED architecture. API LED architecture has three layers. First one is system API. So system API is responsible for connecting with external system. Okay, so what it will do, it will connect with external system and it will take details from there, it will take data from there. Okay, so these two system API. Okay, so first this system API will connect with this external system, travel on tip, and this fast go route and schedule system API will connect with fast go booking system API. Okay, so these two are external system and these two system API connecting with these two external system. So system API is responsible for connecting with external system. Second, process API. So process API is responsible for applying all the business logic. So whatever business logic we will apply inside process API. Okay, now this experience API. So based on experience system, we will have different experience API. For example, you can see here one experience API we have for mobile application and one experience API we have for this web application. Okay, so whatever experience system we will have, for all experience system we will have different experience API. Okay, so in API LED architecture we have three layers: system API responsible for connection with external system, process API responsible for applying all the business logic, and it will connect with, means intermediate in between experience and system API. And this experience API is responsible for different experience system. Okay, whatever client is going to use, like if it can be mobile application, it can be web application, it can be any standalone application. Okay, so for each application we will create different experience API. Okay, next. So next we will discuss about this web application sequence diagram for get route. As I told, we will be focused on get route and get schedule. So we will be focused on two functionality. For two functionality only, total how many API we will create? We will create two experience API, one process API, two system API, and again we will create two external system. Actually, if you will go in real-time project, then you need not require to create these two external system. So we have here two options: either we can mock the data of this experience system, or mock the data of this system external system, or we can implement this external system also. But in actual project, client will provide you this external system. Okay, so there will be different team who will work on this. So as a Mulesoft developer, you will be focused on these three layer. Okay, so this will be provided by any other team, but here we don't have any other team. So what we will do, we have two options as I told: either we can mock this API, data of this API, or we can do implementation. So this time we'll do implementation and we will use DB connector to connect with database. So whatever details we want, we will implement this API also. Okay, and first, so when we will start implementation, we will start with this API. Okay, but for RAML we will follow top to bottom. When we will first we will create RAML for all the API, and then when we will start implementation, we will go from bottom to up. Why? Actually, this API will call these two API. So once we will able to complete these two API, then only we will able to configure this API. Similar way, for this API will call this external system. So once this external system will be ready, then only we will able to implement this API. So we will follow bottom to top approach. Okay, so first we will implement this, then this, then this, and then this. Once we will complete this, then we will implement this too. Okay, so first we will understand sequence diagram, okay, about this gate route of this web application. Okay, so let me maximize this. Let me know if my screen means whatever things are there, everyone able to see, or I need to zoom it more. Okay, fine. I hope everyone able to see. So see. So this one travel on tip. This one is our first external system, and this one fast go booking system is our second external system. If you go to this diagram, so we are representing travel on tip booking system, and we are representing this fast go booking system using this two box. Then we have two system API here. So if you go there, then you can see we have two system API. So we are representing using this two box. Okay, and then we have one process API and one process API, and then two experience API. But there we are working, means we are dealing with this web application sequence diagram. So we are displaying only one box. This is web transport booking experience API. Okay, now we will see how we are doing call and all, and what all logic we have to implement. So currently you need to be focused on gate route. So what this experience API will do, experience API will call this process API to get route. Okay, now this process API don't have data. So what this process API will do, this process API will call this system API. So see here, process API calling this system API, from there this process API getting response, and calling another system API also, this system API also, and from there it's getting response. So this process API calling two system API, similar this process API calling two system API. Okay, next, now this system API calling this external service. If you go here, so this is this system API calling this external service, and this system API calling this external service. Same thing we have implemented here in sequence diagram. So travel on tip system API calling travel on tip booking system, and this fast go system API calling fast go booking external system. Okay, so these two call we are doing, and whatever response we are getting, we are sending final response back to this experience API. Now you can see few more thing we have mentioned. Okay, so what we have mentioned, we will try to understand in different way. So let me create one high level diagram. So we have here experience API. Okay, what this experience API do, it's calling this to this process API. Okay, So this experience API calling this process API, and once this process API will complete execution, it's sending response back to this experience API. Okay, so and once this process API will complete its execution, it will send response back. So here we are doing request, here we are doing response. Okay, now this API we will expose as a REST API. So what we will do, we will use one connector here. What connector we will use? HTTP listener. Okay, let me create one bigger diagram. Then since we will add multiple components, so since I want to expose my this API, experience API as a REST API, so what connector I will use? HTTP listener. And to call this process API, we need one connector. What connector we will use? We will use HTTP requester. Okay, so we have HTTP listener. We want to expose this API as a REST API, and we have HTTP requester to call this API, process API. Okay, now what this process API will do in case of get root? So this process API will call, see, first time it's calling this system API, and then again it's calling this system API. So before that we will go through this whatever written here. Check cache for transport provider route. If could not find, retrieve from transport provider for list of route. Means what they are saying, whenever this process API will get request, so this process API don't have data. So from where it will get data? It will get from system API. Again, system API don't have data. So system API will call external system. So this process API need data. So this process API will call system API. From where system API getting? For now we can leave. System API has data. So system API can give data as a response. Okay. So to get all the route, this process API need to call these two system API. Okay, but what they are saying, check cache for transport provider. They are saying first don't call this external system, first check in cache. Okay, so what can happen, like if you think in real way, like for example, you are checking any route by any transport provider. So generally they create route and all details 3 months 4 months back. Means for example, if I want to see all the flight route of Air India, like Cathay Pacific, then I means for next 3 months I can see on their website. Okay, and very rarely they change their route. Okay, they may change, but very rarely they change. Okay, If let me take any other example, like whenever your result declares, you want to check your result, then in most of the cases, like when you will call your result API, like from where you will go to this website and you will check your result. Okay, you got your result. Okay, after 10 minutes, if you will check again your result, then again you will get same response, like you will get your result. Your marks will not vary. Your marks can vary, but when you go for this copy rechecking and all, okay, then only your result will change. Okay, so every time if you want your result, if that website will call external system and will get data from there, then it will take too much time. So to save time, what they will do, when you will call your, when you will want to check your result, they will store, means first time they will call external system. So first time they will not have any data. So first time they have to call external system, from there they will get result. But next time when you will call, they will check, is there any previous request for the same registration number? If yes, then they will check in cache. Okay, and if they will find result in cache, then they will not call external system again and again. So in that case, what will happen? You will get response very faster. So same thing they are saying here. First check, is there any request made by previous customer? Okay, for same, means is there any request made for, but same means whatever transport provider we have. If yes, like we have their data in cache, then take data from cache, don't call external system. If we have data in cache, then take data from cache only, don't call external system. See, if you will call external system, then external system will take more time to give you response. But if you have that data already in cache, okay, then it will take relatively very less time. Okay, that's why they are saying, if data is available in cache, then take from cache only. If not available, then call external system. So that thing they want to say here. And then second thing they are saying, no dependency to fetch code from each transport provider. Means this transport provider will give different set of route. This transport provider will give different set of route. So we don't have any dependency, as I explained 10 minutes back. Like we can call two external system in sequential way, or also in parallel way also. But when we should call in sequential way, when they are dependent of each other. One API request is dependent of another API response, then we should call in sequential way. But here they are saying this two system API is not dependent on each other. In diagram also you can see this system API calling this system API calling this system, and they are getting request from here. They are not dependent on each other. So in that case, what we should do, instead of calling one by one, we should call in parallel way. Okay, so again I will use one HTTP listener to expose this API as a REST API. So again we will expose our process API as a REST API, and we will use two HTTP requester to call different system API. Okay, first this HTTP requester we will use to call this one travel on tip, and this HTTP requester we will use to call EasyGo only, na, I forgot company name, Fastgo. Either we can call parallelly or we can call sequentially also. But if we will call sequentially, then see what will happen. If this call taking 5 seconds and this call taking 5 seconds, total time will be 10 seconds. but these two are independent of each other. If we will do parallel call, then total time will be 5 seconds. So which one is more efficient? This one is more efficient. Okay, so based on requirement, you have to take decision how you will do external API call and all, which component you will use. So for doing parallel call, we have scatter and gather. So I'm not sure everyone familiar with this or not, but yes, we have one component. Okay, parallelly I will show you that component so you will get more clear idea. So let me create one new workspace. Okay, better. Okay, so workspace name I am giving this, and I will suggest everyone, when you will start working on this real-time project, create new workspace. And all the API, like whatever we have, like I think 3 to 7 API we have, we will create all the API in this workspace. Okay, so okay, you can't see mule component, so I will create one dummy project first. Okay, so inside code component we have, okay, so let me create rough diagram here only. So in HTTP, first we will use listener to expose our API as a REST API. Then I want to call two system API. So either we can call okay, if I want to call two external system, we can use two requester one by one. So what it will do, first it will call one external system, then we will get response, then it will call another external system. But these two call are independent of each other, then we can use one component, scatter and gather. Okay, so what will happen in case of scatter gather, we can call this scatter gather, whatever branch we will define, all branch will run parallelly. Okay, so what will happen in this case, this branch will also run parallelly, this branch will also run parallelly. So it will save our time, save our API time. Our API will be more time effective, like it will take less time. Okay, so same thing I am explaining here. Okay, so we have two HTTP listener and we will use scatter gather. Okay, okay, till this point everyone clear? Now what they are saying now, okay, in normal flow, don't forget about this point. If we ignore this point, then what will happen in normal case, we are calling this system API and we are calling another system API. So we have to create two system API here. Okay, so let me create two system API. Okay, so we have two system API. So this requester will call this API and this requester will call this API. Okay, again these two are API, so we will use HTTP listener to expose as a REST API. Fine. Now these two these two system API will call external system to get response. Okay, so these two API also need HTTP requester. This also need, and this API also need. Okay, so we'll create two more external system. So this is first external system and this is second external. These two are also API. Okay, so these two all will also contain listener and then okay, they are going to take data from database. So instead of requester there will be DB connector. Here also we will have DB connector. So this will call this. So this HTTP requester will call this API and this HTTP requester call this API. Okay, so I hope everyone clear till this point. Okay, this one is normal flow, but okay, let me clear my cache file. Sorry, just give me 1 minute. Okay, so this one is system API. Let me name it system API. And this one is also system API. And this one is external system. And this one is also external system. Name is, what was the name of external system? One was travel on tip and fast go. So this one is fast go. This one is travel on tip. Okay, now we will focus on this point what I asked to ignore. So what they are saying, first this one, check. Okay, first this one we already implemented. No dependency to fetch code from each transport provider. So we are using this scatter gather. We are doing parallel call. Okay, instead of doing sequential call, we are doing parallel call. So this point we already implemented. Now check cache for transport provider. What they are saying, don't call this system API directly. First check, do we have whatever request we are getting, do we have data in cache? Okay, if we have data in cache, then use cache data. Don't call this external system. Okay, so what we will do here, we will implement cache here also and here also. So what will happen whenever this API will get request, first it will check in this cache, do we have response for whatever request they receive. If response is there, then it will not call this API. Again, this API will not call this API. So we will save this API call time. Like if it is taking 5 seconds, if it is taking 5 seconds, so instead of taking time 10 seconds, we will get response from cache in 1 second. So we can save 9 seconds. I am just taking rough example. ID means actual time may be different, but ratio will be similar kind of ratio. Okay. So we are getting for what request we are taking 10 seconds, we are getting response in 1 second only. So that's why they suggested to use cache to store our request. Now you will say first time from where cache will get data. Since actual data is not inside cache, actual data we will get from external system, and that external system will get from database. So whenever it will get new request, so first time it will call this system API. System API will call this external system, will get data, then it will pass that data to this HTTP requester. Since we have defined this HTTP requester inside this cache, so what it will do, when it will get response first time, then it will restore that response inside cache. Now second time, if we are getting new request, then it will check in cache, do we have this, do we have response for this request. Since we don't have, then it will again call this system API. Then system API will call external system, will get data and will send data, and we will store that response in cache. Now third time again we are getting new request, then again this system API will check in cache, do we have this data. No, again we don't have. Then again it will call system API will call external system, will get response, here. It response will be saved in cache, and then it will back to this process API. Now in fourth time we got same request what we called in second time. Then what it will do, it will again check in cache. Oh yes, this request we already made before before 5 minutes or 10 minutes, and we have response for that. Then what it will do, it will not call this external system, this system API. It will take response from cache and revert back. So in that case our processing will be faster. So here two out of box capability we are using. First we are using this cache to store response, and then we are using scatter gather. So using this two out of box capability, we are making our API very faster. So if you remember, we discussed one point here. Make use of Mule out of box capabilities. Okay, so what all two capability we are using here? One we are using cache, another one scatter gather. Let me know if anyone has any doubt. So when we will do implementation, we will do same thing. We will do implementation like this only, means these all are API. So we have to create one API as a experience API will be two. This one for web application, another one we will have for mobile application. There will be one process API for both. Okay, and then this process API will call this to external system, and system API, and this system API will call this external system, this system API will call this external system. Okay, all of these are REST API. So to expose our API, we will use HTTP listener. To call any REST API, we will use HTTP requester. And here we want to connect with database, so we will use DB connector. Later on we will see, we'll introduce more connector, how we will introduce, I will think and I will update you. So we will change in our design, and I will try to introduce more connectors so you will have more idea of connectors and all. Okay, so till this point I hope everyone clear. Later on after this session I will take 10-minute doubt session. So if you will have anything you want to recap, means you want to explain me again, then I will explain. So this sequence diagram we have for gate route. Next sequence diagram we have gate schedule. So here also you can see there are many things. So first, this experience system will call this process API, similar to this. This experience API will call this process API. Then this process API will call two external system. One for travel on tip, this call, and another one for first go. So here also they have given multiple conditions. So we'll see. No dependency to fetch code from each transport provider. Again they are saying these two transport provider means we don't have any dependency to get data from these two system API. So we can do again parallel call, and for parallel call what we will use? We will use scatter gather. So here we are doing this call and this call parallelly based on company code to determine which system to retrieve the schedule list from. So what they are saying, they will pass company code. Okay, we want to get data from travel on tip or we want to get data from fast go. So whatever company code they will provide, we will call only those system API. We will not call both. In case of get route, we are calling both at a time. Since we don't have any filter condition, so we are calling both. But in case of get schedule, what they are saying, based on company code, whatever company code they will provide, we will call only that external API and we will return only that data. For example, I want to get schedule for first go or first go, then why I will call this travel on tip? I will call only first go. I will not call this. Invoke each transport provider booking system are not dependent on each other. We already mentioned. Okay, one more thing. If they will not provide any company code, actually here I forgot to mention, but I will mention later on. If they will not provide any company code, for example, if they are providing, I want schedule for only fast go, then I will call only fast go. If they will mention I want data from only travel on tip, then we will call only travel on tip. But if they will, means if we will not get any transport provider, in that case we will call both. If we are getting transport provider, then we will call only one. If we are not getting, then we will call both. So how we will implement this? Let me create this also, so then you will have better understanding. So I'm creating one duplicate first. Okay, so let me make it bigger. So what exactly we want to do? So before this, what we will do, we will apply one choice router. Okay, and this choice router will be let me do one thing. We are exposing this API as a REST API again. Okay, and then we will apply choice router. Okay, so for that, let me divide in three parts. This one is first part, this one is second part, and this one is first part, third part. Okay, in first part, what I will do, I will check company code. If company code equals to travel on tip, then what we will do, we will use HTTP listener and we will keep inside this only. We will keep inside this caching only, and then we will call only travel on tip system API. Okay, if we are getting this condition, if we are getting condition, if company code is fast go, then what we will do, we will call only this fast go. But if we are not getting any company code, then inside this we will use scatter gather. Okay, so inside this we will use, okay, let me use this only. And we will use scatter gather inside this Okay, so here we will call these two parallelly, okay, using scatter gather, and we will have everything inside cache. Okay, and this will call this, okay, let me call this also, this will call this, and this will call this. Okay, so what they are saying here, based on company code to determine which system to retrieve the schedule list. If we are getting company code travel on tip, then we will call only travel and tip. If we are getting company code fast go, then we will call only fast go system API to get all the routes. But if we are not getting any company code, in that case we will call this travel, whatever system we have, travel on tip, easy go. If there is any third system, then we will call that third system also. But we have only two systems, so we will call only two system API. Everyone clear with this requirement? So in this case, in case of schedule, you have to call in this way. First you will create HTTP listener, then you will create one choice router. So you can see choice router here. So we have this choice router. So before this scatter gather, we will have choice router. Okay, so in one case we will call only one route, only one system API. In another case again we will call only one system API, and in next case we will use those two system API. If we have travel on tip, then we will call only travel and tip. If we have easy go in company code, then we will call only easy go. If we don't have any company code, then we will call all the all the system API, all the travel tip also and easy go also. And one more thing about caching. So how we will do caching? Actually here we are not doing actual implementation. I am just going through all the components, so while implementation you will have some idea. So for caching, actually we have here. So this will be inside this, what we have created in diagram. Same, this requester will be inside this caching. So how we will configure, I will explain later. This will be inside this. Okay, so in this way we will do our implementation. Okay, this is just high level. Okay, now, so everyone clear with this? Any doubt? Okay, anyhow I will pass this recording, so you will go through again and you will try to understand. Last thing is travel tip API is still okay. No, this part we will remove. Actually we have implementation of all the API. Now map transport provider location code to the common location code. Okay, what they are saying, for transport provider, when we will get response from system API, we will get transport provider location code. Okay, what they are saying, we will map with common location code. Okay, for example we have travel and tip. For travel and tip, on travel on tip, they are using Singapore as a SGP, and we have another one is EasyGo. They are using Singapore code as a SG only. So if we will pass both different SGP and SG, then it may create some confusion for this process API or for experience API. So what we will do, we know, means that kind of requirement architect will tell, like from this system API travel on tip, for SGP you will get, for Singapore you will get SGP, for AG-Go you will get SG. So instead of keeping as a SGP and SG, make it common. So what common we will create? Either we can create SGP, we can create SG, or we can create new common code. That will be our understanding. Okay, so based on our understanding, so for example for Singapore we will create SGP only. Okay, for example from one place we are getting SP and one place we are getting SG. So to make it common, what we will do, we will convert SP also in SGP and SG also in SGP. So what we are doing, we are changing that location code to common location code. Okay, so before passing data from process API to experience API, we will do this mapping. At this point you may not be clear with this point, so leave it for later point, like when we will do actual implementation. At that time I will explain this again. Okay, so you need not require to worry about this. Ensure formatting as per request from the front-end application. So whatever formatting they want JSON payload or what they want, we will convert in that format. Add location description mapping from location description file. So what they are saying, now we are passing SGP as a source or destination code, as a code we are passing. But what they are saying, in one file they have given complete name also. For SGP complete name will be Singapore. So we will get this data in one file, so we will read that file and we will do that mapping. For this also you can, for now you can leave this part. When we will implement this API I will explain it again. Okay, so what exactly they mean to say, we will get one response from here, one response from here, means one response we are getting this, one response we are getting this. So what we will do, when we will send this response from process to experience API, we will make it common response. Experience API will not able to, since experience API need only one format, but from this two system API we may get different format. So we will convert in common format and then we will pass to experience API. So for that we will use transformation. That's why transformation came in the picture. Okay, so whatever I explained till this point, this is for web application. Okay, now for mobile application also we have almost similar thing. Okay, 90% things are same, only 10% change are there. So instead of explaining this again, I will we will avoid again, like while implementation I will tell you only slight difference is there, I will explain that slight difference, but 90% thing will be same what we are implementing in web application. So for mobile application almost everything will be same. So this sequence diagram we can skip for now. Now one by one they will provide you detail of each API. Okay, so we'll start with experience API. So how many experience API we have? We have two experience API. If you go at the top of this diagram, you can see here we have two experience API. So one by one they have shared detail of this experience API also and this experience API also. Okay, so first we will discuss about this. I am not sure which one is there. Let me go through there. Okay, experience API. Okay, this is common for both the experience API. Okay, I will update this diagram a bit, like I will create one experience API for web application and one for mobile application. Let's assume this one is for web application. Okay, so here first one is retrieve consolidated root. Okay, so this one is one functionality inside this experience API. So they have shared all the detail for that. So our resource will be roots. Okay, and then when we will create this API, our method should be get. Why we are using get method? Since we want to retrieve information, retrieve resource detail. Okay, so as I told, in API like REST API, we have multiple methods like get, post, put, patch, delete. Get when we will use when we want to retrieve resource. So here we want to retrieve resource, we want to get the root of transport provider, so we are using get method. Next they have given URL. So URL contain resource name, then URI parameter, all those things will come inside URL. So here you can see we have booking, then whatever things you will get inside curly bracket means that is URI parameter. Okay, so in any API we can pass input in multiple format. Either we can pass in query parameter, or we can pass in URI parameter, or we can pass inside header, or we can pass inside body. Okay, so URI parameter is one of them. We can pass some input. Okay, URI parameter is a kind of nested resource. If you have gone through recording of my API session, at that time I have explained about all this. Again I am explaining. This booking is our resource. Okay, inside this we have nested resources transport type. Transport type means we want bus service, we want flight service, or we want train service. So what kind of transport we want, and then route is our resource. Okay, so this all are part of our URL. So when we will implement our API, so first there will be booking. Under booking we will have transport type, and then inside transport type we will have route resource. Okay, so tomorrow we will implement RAML, so I will explain again, and based on this we will create RAML. Actually I will not create today. Actually first you also need to go through requirement, you have to understand, and then we'll work on this RAML tomorrow. Okay, now what this objective of this particular API? To consolidate route from multiple transport provider. Okay, now in header, as I told, we can pass input in multiple format, either in URI parameter, in header, in query parameter, or in body. Since this one is get method, so get method don't have any body, so we can pass in header and query parameter. Now in header also we will have one element, that is transaction ID. So this ID we will use for logging purpose. Either we can keep name as a transaction ID, we can keep as a message ID. Okay, for logging purpose, for example, many user will call our API at a time. If someone fail to get the response from our API and they are claiming like I called your API but I am not getting any response, so how we will track about that user? So with the help of this transaction ID, so when they will do login, and they will do login in front end system like web application, and when they will make this call, so front end system web application will send some transaction ID, and we will record that transaction ID in our log. Okay, so logging is very important when you do any development. If you will not apply proper logging mechanism, then while supporting your API, like when it will go to production and all, it will be very difficult to monitor your API. when your API is failing, where exactly it's failing. So logging is very important. So in header we will pass transaction ID and value will be like this. This one is mandatory. So when you will define raml, so when you will define this header in raml, make it mandatory and data type will be string. In similar way, we will have three query parameter: company name, departure location, destination location. All are mandatory and means optional. If user will provide, means from front end, if we will get company name, okay, this company name logic in get root also. So whatever we have implemented now in this diagram, so same diagram will be for get root also. Okay, here also we will get company code, and based on company code, if we are getting company code, then we will check matching with travel on tip, then we will call only travel into. If we are getting fast go, then we will call only fast go. If we are not getting any company code, then we will call all. But this one is our experience API. So in experience API we are getting, so here we will not apply that logic, we will just pass that value to process API. As I told, process API is responsible for applying all the business logic. So here we will not apply business logic. Here we front-end system will give that company code, we will just pass that company code to process API. Process API will implement this logic. Okay, that's why in field rule you can't see any description, but when you will go to process API, you will get some description. Okay, so based on this detail we will create raml from tomorrow. Just try to understand all this requirement. In output we will get this kind of JSON payload. Okay, so we will get company code in case of root, company code, and then location. Location will be Bangalore to BNG to SG, means location code is that is Bangladesh to Singapore. Okay, location description, okay, sorry, it's not Bangladesh, Buona Vista location code, location description, yeah, Buona Vista Singapore. Okay, so in this way we will get this kind of response. Okay, again response we will discuss in detail later on. Just try to understand. In response we will have multiple payload. Okay, we will get all the roots roots detail. In roots detail we will have transport provider with origin location and destination location. Okay, then for retrieve consolidated schedules, in schedule also you can see we have booking, then we have URI parameter, then you can see we have different resource. Okay, so inside booking we have transport type, and inside transport type we will have two resource, one will be route, another one will be schedule. Okay, so when you will create raml, so parent resource will be booking, inside booking we will have nested resource transport type, and inside transport type we will have two resource, one is route and one is schedule. For route we have seen all the description. Now for schedule also we will have some description here. Schedule will also have transaction ID in header, and it will have some query parameter. Okay, so this, while creating raml we will go through all this and we will implement. So for today actually I will not take too much things, so otherwise it will be difficult for you to understand, and this one is response format. Okay, so I hope everyone clear till this point. Let me stop recording and then I will take all of your query.